Hello, you're watching Exeter and Lara, and I've put together a video showing basically how Electrofrog points work and also Insulfrog as well. I'm not going to go into too much detail about the Insulfrog because I'm not using him on my layout at all. But obviously I've kind of sat down in recent weeks and looked over a lot of YouTube videos, and though there are quite a few out there that explain Electrofrog points and how they work with point motors, it still leaves you scratching your head at the end of the video. There are some good ones out there, but I do find that a lot of videos that are sort of giving you a demonstration of how things work kind of leave a few things missing in between, still making it difficult to understand. So hopefully this video that I do now will kind of put everything together so people understand how exactly it all works. Okay, so all I've got here at the moment, as I'm shooting this video, is Electrofrog points. So I'll talk you through the differences between the two. I did shoot a clip a couple of weeks ago when I actually had an Insulfrog point. So I will cut to that in a bit and show you the difference of, or basically how the Insulfrog point works. But this being the Electrofrog one, and difference is this part here is all metal, whereas on the Insulfrog it's plastic. Basically these are okay, they're good points, the best thing to use on a model railway if you want all your trains to flow over your point properly. These are the way forward, and they look more realistic because obviously all this is metal. So these, you can use these straight out of the box, connect straight to your railway, and they'll work without any modifications. Likewise, the same with the Insulfrog. You can fit point motors to the Insulfrog, but I find that these are the best way forward, I think, for getting your trains running around successfully. What I'll do now is I'll just quickly cut to a brief description on the Insulfrog point, so that kind of gets that part of it out of the way, so anyone who's using the Insulfrog points kind of know how it all works. And I shall be right back and explain how the Electrofrog point works. Okay, so starting with the Insulfrog, excuse me, I shall give you a quick rundown of exactly how they work. So basically, if you look at where the frog is on the point, and this all of it is plastic, this little bit here will be plastic, so basically everything is insulated from these little bits here right the way back to here. So if we turn it over, you'll see there's two pieces of wire which bypass the frog basically from underneath. So if we switch, let's switch the point over so the contact blades are made contact onto this side of the rail here, and let's say that this is your plus. So your plus is going to run across these blades as long as you've got a good source of contact here and it's not too dirty. So your plus is going to run all the way to here, it's going to get to the insulated part of the frog, and then the power is going to go underneath into this wire, the bottom wire, and then it's going to come back up the other side of the frog and then rejoin onto that part of the rail there. And it's likewise if you flick the point that way, your negative is now contactable on the blade, runs up to there, obviously up to the point where the frog is, and then diverts through the wire, across, and then back out, and then joins that rail just there. And that's basically all it is with an Insulfrog. Okay, so the Electrofrog point, basically, if we turn them over, you have, there's a join in the rail, so there'll be a gap between this rail and that rail, and that's bridged by this piece of wire here. When these are new out of the box, also they have a piece of wire connected from there, which is normally 4 or 5 inches long, and I'll tell you what that would be for in a little while. So as I say, these are fine out of the box. They'll work for a while, then eventually with a bit of dirt build up you'll get grime in there, and when you come to flick the point you'll lose the conduct of the electricity between the blades. So these are vital to keep clean if you're not going to use a point motor, and you could end up with potential problems with obviously short circuiting as well. Okay, so I find the best way to probably explain how it all works is to actually use Peco's templates for the points, and with a felt tip pen coloured in exactly where the electric flows with the switch of the blades. As I was saying, you've got to rely on making sure that these points here are clean to make sure that the electric flows where it needs to go. So as you can see here, with the blade switched over to the negative side, everything that's highlighted in the blue is everything that will become negative. And likewise, when it's switched the other way, it switches all the power over to the other side. So you're relying on having the clean contact points there and there for it all to work properly. There's no other modifications that you need to make to the point. The only thing I would say that you will need to make sure that you've got the insulated rail joiners to make sure that you don't short anything out when you flick the switch. If you're going to use point motors on these, depending on whatever type you're using, you don't need the polarity switch because you're not using obviously the point to switch the polarity, it's doing it all itself. So hopefully that makes a bit of sense, I suppose, by looking at the pictures to see where it all flows and which, you know, where the current is flowing on the switch of the blades. And another disadvantage about the using these points without the point motor is this area here where you've got obviously the negative flowing through this blade here and you're quite close to the positive. And this is where a lot of people get the problems with when they've got trains passing over this area, is if you've got your typical, let's say, Hornby, which has got quite wide wheels, you might find that with the wheels on that rail may just bridge over and touch that rail, which then in inverse causes a short circuit. So this seems to be probably one of the biggest problems that people get using Electrofrog points without a point motor. So what I'm going to do is move on to the modifications that are needed to these points to get it ready for using a point motor. Okay, so you've got this one out of the box and it's ready to go, all minus the fact that it hasn't got the piece of wire there, because these are actually second hand and would have most likely been used on the layout without the use of a point motor. So the modifications are, and if probably people will know this if you've watched a good few videos, is these have got to be cut, these two pieces of wire, clean completely away so they're not hanging around and, you know, making the circuit again. And then with this cut out here, you've got to solder a piece of wire from that rail to that rail, and then the same again with that rail to that rail. And this will become apparent in a minute when I do show you the next clip. Okay, so with the modifications to the point and exactly how they work if you've got the point motor now connected using the polarity switch, this shows you exactly how the current flows through the point. So with the switch blade set in that position, the polarity switch that's built in with the point motor will switch all this area to the positive current, and because you've severed the track or that wire that's underneath, and you've got that bridge running from there to there, it keeps all this area here in the negative, which means that any trains that run through this bit here, it's both these rails here remain negative, which means that you'll never get the short circuit if the wheels were to bridge across over to the other side. And it's likewise if you flick the point the other way with the help of the point motor, switching the polarity, it then changes the frog up to that point there to the same current as what its point blade is touching onto that rail. And again, because you've made the sever in that wire and connected that one from there, it keeps the current flowing with the correct one along this piece here. So it's as simple as that. That's exactly how it works by using the point motors. I think now from this point onwards, a lot of people find that wiring up the point motors is actually quite confusing. Again, you know, there's a good few videos on there. Some of them are quite good and some of them leave you thinking, oh God, how does that work? That's a bit confusing. So again, I'm going to come up with another clip which shows you exactly how the setup works that I'm using. And as with the beginning of the video, you probably noticed that there was a mcdu unit, capacitor discharge unit, which is gaugemaster, and obviously the gaugemaster seep PM1 point motor. So that's using this one, which comes with the built-in polarity switch. People may get this out of the packet and think, oh God, but it's actually quite easy to wire up. Bit of soldering skills needed, but it's actually quite straightforward. And my mcdu unit is an out-the-box thing, comes with a plug in the wall, so it's hardwired, and this in itself will power every single point that I'm going to have on my layout. This is all I need. I don't need any other additional power. This is just straight in to a plug socket, and then basically everything's running. So I will now give you kind of a illustrated diagram of exactly how this works, along with the point motor, and how the point motor does all the work to create this, basically the switch over of polarity. Okay, so hopefully, just try and get that in the picture a bit more at the top. This gives you a clear idea of exactly how it works by using that mcdu capacitor discharge unit. Anyone who's probably followed a few videos or watched a few might have probably most likely stumbled across Everard Junction and how he wired up his CPM1 motors. He didn't use the CDU units. Whether he had them on the layout, I don't know. I know that he had a separate bus wire which was connected to, I think it was a 12 volt standard controller, and used that for his bus wire to control all of his points. The only problem you get with that is every time you flick a point you end up with a buzzing noise. So the discharge unit in itself sends a burst of power to the point motor which stops the buzzing noise. And these switches are the ones that will always set themselves back to the middle again. So if I was to flick the switch in that way, it would set itself back into the middle again. And that in itself, along with the capacitor discharge unit, stops the motors from burning out, because you haven't got that constant flow of electric running through that when you're not using it, which burns the coils out. This shows basically a simple 1-point setup. But this, as I say, this discharge unit, the power supply from that will power every single point on my layout, and that's all I need. I don't need another one of these to power another point and so forth. It would do the whole lot. So this would be a case of, I'll have the 2 wires coming out of here, which will go into a terminal block, and then from that terminal block I will distribute a number of wires around the layout to any area where there's a bundle of points, and then so forth. So basically, you've got the terminals on the point motor, and terminal F is the one that powers the frog of the point. So that's the one that actually switches from the positive to the negative. The minus and the plus there for the DCC bus wire is your feed that gives you the power whether it would be the positive or the negative for terminal F for the frog point. So these are connected straight into your bus wire that basically powers all your track, and that is done by, which I'll show you in a minute, exactly how this point motor works. And then of course from the CDU unit you've got your switch, which runs down to the middle pole of your switch, and then of course you've got your switch wires either side, A and B, and then you've got your common, which runs from there up into terminal C of the point motor. Worthy, if anyone sort of wants to get a clear picture of this, is to take a screenshot of this, and it will give you a better idea. At least if you've got that screenshot, you can always look back on it and go, ah, yeah, that's how it's done. So I think that covers that. Yeah, so once I got my head around it, it was pretty straightforward. So looking at the point motor and how that works and how that switches the polarity, let's try and get a nice clear shot underneath there. If you look where the tie bar is, there's a small washer just there, just underneath that spring. There's a small washer, and what that does is every time you flick the point, it will line that washer up with terminal D, as you can see where it's lined up now. So it will be drawing the power from terminal D on there, which is the plus of the DCC wire, and it will bring that around the back of there and then bring it out through terminal F, which obviously then goes off to your frog. So with the flick of the switch, when it puts it the other way over to point E, it will then be picking up the minus of the DCC bus wire round into terminal F, then off to your frog. So that's how that works. So it switches by that, and it depends on that washer of the contact of the circuit board there to flow the electric the correct way. And one of the things is with these is you've got to make sure once they're all wired up and you put them underneath your baseboard into your point, is that these have got to be the right way round, because if you go the wrong way round with them, you might find that you might be putting the charge of either positive into a negative track and vice versa. So making sure that you got them the correct way round. So they're as simple as that, really. Okay, so I'm hoping really that obviously people would understand that. As I say, what I'll do is I'll leave the camera here for a couple of seconds. If you again want to get a screenshot of that, best way to do it, that way you'll understand exactly how it works. Obviously referring back to the beginning of the video with the necessary modifications that you need to make to these points. Pretty straightforward. I will note some Electrofrog points, which might be the older versions of the peco ones, actually don't have this gap in the rail there. So if you do stumble across them and you think, well, hang on a minute, my point hasn't got no wire that I need to snip off the back, how do I get around that? And I've got a few points like that around the layout. What I've done is a Dremel tool, and I've just cut through the rail just to sever, so this whole area that's red where the frog is, wherever my pen is there, is separated from these areas back to there. And again, I'm using all gaugemaster stuff. My whole layout's going to be controlled and all powered by gaugemaster, which is why I've gone to the trouble of using the seep PM1 motors. I know people think, oh god, I've got to solder all that up, that's going to take ages, but to be honest with you, it's easy. It takes about 5 minutes, I suppose, just to stick all your wires on there. Best always just to colour coordinate so you know what's what. I don't know much about the peco point motors. I haven't got any and I don't plan to buy any, so if you decide to use the peco ones, I do know that they come with a separate accessory switch, I think, which you clip onto the bottom. But again, there are other videos out there that show you how they work. So hopefully that makes it a little bit more understanding. And for anyone who wants to know about these, as I say, these are straight out of the box. So you buy these, I actually paid, I think it was about 15 quid for this, which was quite a good deal, because I think they retail about 25. Some people may say, well, that's a bit expensive compared to when you can just buy a plain capacitor discharge unit and just wire it all up yourself. But this is great because it comes with the plug, so it just meant that straight out of the box, connects a couple of wires up and off you go, rather than complicating things even more. So yeah, these are good, 25 quid and it works wonders. And I say, everything on my layout's going to be gaugemaster, so I wanted to keep everything within one brand, basically, so hence the reason why I picked the PM 1-point motors. And I've also got a few points on my layout which don't have the springs and the latching mechanisms, so I'm going to be switching them ones over by using the PM4, which have a built-in latch, which obviously keeps the point locked into position. But again, that will be a future video which will show you how they work and how I solder them up and fit them, etc. So hopefully that should be it. So basically what I'm going to do now is end the video. Want everyone to like, share, subscribe. Any comments, again, just add them into the bottom. I'll try my best to answer whatever I can with whatever knowledge I've got. So yeah, and I should be back. I don't think I'm going to be back at the end of the month with a monthly update, simply because there hasn't been much progress up in the loft. A lot of the stuff I've been doing is more so downstairs, soldering drop of wires to pieces of rail and preparing point motors. So the layout, and also it's been quite cold, and it's not the nicest place to be in, a bit of a chilly loft. Even though I've got the insulation up there, it's still cold. But I will be back, possibly, if not with an update, some possible how-to videos. So I have got another one due up, which involves another Class 50, which is a how-to video. That's due, so keep your eyes open for that. Also as well, I want to point people towards my Facebook page as well. If anyone's familiar with the Scrapline model railway weathering, that's on Facebook, but that page is actually going to be taken down within the next week or so because I don't really use it. There is another one called Exeter and Lara. I think it's called Modelling Exeter and Lara. Have a search for it because it's there, and there's obviously updates on there which aren't mentioned on the YouTube channel. So, and it keeps everyone up together with what's going on. So yeah, do look for that. And I'm going to leave it there and speak to you all again soon.